Welcome to our last section in Chapter 1, Section 1.9, which is probability. So what is probability? Well, probability is the likelihood that an event is going to occur. We're going to define probability or write it as P of whatever event. It could be something like if we are flipping a coin, the probability of heads landing. It could be something of throwing a die, the probability of a 5 being rolled. We're going to define it as the number of winners, number of favorable outcomes, divided by the number of possibilities. So the number of ways that we can play or the number of possible outcomes that we've got. So it brings up the question, what's the largest probability of an event? And also, what's the smallest probability of an event and why? Well, the largest probability is something that's always going to occur. Every single time we play, we win. So in that case, the number of winners is the same as the number of possibilities. So let's say, for instance, we had 7 different possible outcomes, and they were all winners. Our fraction we would write is 7 over 7, but because we want to reduce our probabilities always, 7 over 7 is going to reduce down to 1. So the largest probability of an event would be 1. The smallest would be when something never occurs. No matter how many times you play, you cannot win. So if there were 7 possibilities, but none of those are winning events, then our probability would be 0 over 7, or 0. Largest probability is 1, smallest probability is 0. All other probabilities will be in between those numbers 0 and 1. So let's look at some examples here. In the first one it says, if one of the following angles is angles is selected at random, so that means that we're just kind of randomly picking one, we want to know the probability that it's acute. So by definition, an acute angle is one that is less than 90 degrees but also greater than 0. So I'm looking at my 4 angles that I've got here, and I'm looking for acute angles are winners. Well, this one's a straight angle, 180 degrees, I assume that. This one's 125, so that would be obtuse. This angle's 90 degrees, so it's a right angle. This one is 42 degrees, so that's an acute angle. Now, we want to know the probability of winning. So our probability of acute we have 1 winner, 4 angles. There's 4 angles we could have picked. We picked the acute angle. That cannot reduce, so there's really nothing else we can do with that problem. Changing up the example, if one of the following angles is selected at random, what's the probability that it is not a right angle? So again, not meaning that anything that isn't a right angle is a winner. So we go back to our straight angle, that's a winner. 125 is a winner. And 42 is a winner. So our probability of a not right angle is 1, 2, 3 winners out of 4 angles. And for the next one, it says what's the probability that it is straight or right? So we have 2 possibilities, a straight angle or a right angle. So we know the straight angle is a winner, and we know the right angle is a winner. The 125 and the 42 are not. So our probability of straight or right equals 2 over 4, and this is where we're going to run into a problem if we don't reduce it. We want to make sure our fractions are always reduced. 1/2. What that basically means is half of the times we play in the long run, we will win. So we'll have either a straight angle or a right angle. The other half, we won't. Alright, and then the last one for this type, and then we'll get into someone with points. What's the probability that we have a 57 degree angle? Well, I have a straight angle, 125, 90, and 42. I don't see any mention of anything having a 57 degree angle, so it doesn't seem like I have any winning possibilities, any winning combinations. So the probability of 57 degrees is 0 out of 4, which is 0. Again, you always want to make sure that you have a reduced fraction for your final answer if it needs to be. We can also do this when we have some points. So it says if one of the following points is selected at random, we want to know the probability that it is between C and F. Now remember, to be between, points have to be on the same line. You can't pick a point and say, well, it's between, it just seems like it. Well, it's got to be on that line. So kind of highlight where C and F are. So if we are picking a random point, we got 1, 2, 3, 4, 5, 6 possibilities, 6 points we can pick. We want to know the probability that's between C and F, not including C and F, but between that. Well, looking at my events here, it looks like point D and point E fit that bill. So the probability of my event, we'll just call it event because you guys can see what that is. There's 2, and there's 6 total angles. I'm going to reduce that 2 out of 6. I get 1/3. So 1 out of every 3 times we play, in the long run, we will have a favorable outcome. Alright, one more quick one, and then we will be done with Chapter 1. So this one we want to know what's the probability that the point is on line BF. So again, we've got our 6 points. We haven't changed that. The only thing we've changed is the question. We've got 1, 2, 3, 4, 5 points that are on BF, and the 6th one is not. That's point A that's just kind of floating to the side. So we're going to call this the probability of BF and we said there were 5 that were on there out of 6 total. Now we cannot reduce that at all, so our problem is done. And that's it for basic probability stuff.